TCP IP is a protocol suite that defines how devices should be connected over the internet and how data should be transmitted between those devices. But first, I'm taking you on a quick tour of how the protocol actually came to be. Parts of TCP IP date back to 1973 and Xerox, although the real development leaps came when DARPA contacted Stanford University, BBN Technologies, and the University College in London to develop a protocol that would work throughout different hardware platforms. So this is a very big collaboration. After the test in 1975, when communication between networks at Stanford and the University College in London was performed, things started moving faster. In 1983, ARPANET migrated to the TCP IP protocol stack. By then, the US Department of Defense had already declared TCP IP as the standard for military networking. A few years later, TCP IP managed to find its way into commercial use, which resulted in widespread implementation of TCP IP. TCP IP is actually two protocols, but they're used together so often that people think of them as a single protocol. TCP operates at layer 4 and is responsible for making sure that when a source device sends data, that data arrives at its destination. IP operates at layer 3 and is responsible for the transmission of data. It doesn't do any error correction itself. The TCP IP reference model is similar to the OSI model. It also separates data communication into layers. However, it predates the OSI model and consists of only 4 layers. The TCP IP model provides a common reference for maintaining consistency within all types of network protocols and services. It's not intended to be an implementation specific or provide sufficient detail to precisely define the services of the network architecture. The primary purpose of this reference model is to help you understand the functions and processes that are involved in data communication. Now let's take a look at the layers, shall we? The data link layer is known as the network access layer and is the equivalent of both the physical and the data link layers in the OSI model. It deals with components such as cables, connectors, and network cards, like in OSI layer 1. Like OSI layer 2, the link layer of the TCP IP model is concerned with hardware addresses. OSI layer 3 is the same as the internet layer TCP IP. It routes data from the source to the destination. It does this by defining the packet and the addressing scheme, moving data between the link and transport layers, routing packets of data to remote hosts, and performing fragmentation and reassembly of data packets. This is the layer where IP operates. Another layer that's the same in both models is the transport layer. Even the name is the same. This layer is the core of the TCP IP architecture. It's where TCP and UDP operate. This layer provides communication services directly to the application processes that are running on network hosts. The last layer is where TCP IP makes it simple for us. If we compare it to the OSI model, it actually bundles up the session, presentation, and application layers together. It provides applications for file transfer, network troubleshooting, and internet activities. It also supports network application programming interfaces, which allow programs that have been created for a particular operating system to access the network.